today. Today, we're talking about security architecture. Now, when you hear the term security architecture, it may seem complicated, but it's really not. I'm going to break it down. So, I encourage you to just take a minute to reach out to someone and say, hey, this is what we learned today, and I want to tell you about it. One of the best ways to learn is to teach. This is why I absolutely love teaching, because then I get to reinforce my own understanding and my own learning. Oh, Nora, good to see you. Paul, good to see you. Thank you both for turning your cameras on. I saw you, Hamed, for a second there. We're managing, need more time to study. Yep, okay. That I see that thing there. Yeah, definitely get in touch with your success managers. Okay, that being said, let me go ahead and start sharing my screen so that we can go ahead and get started. All right. So at this point, everyone should see my security architecture screen. Okay. Okay, so we do have a good amount of material to go through, but I'm going to break it down bit by bit. This will be a normal paced class. I'm not going to go any faster than I usually do. So the first thing to understand is when we're talking about security architecture, I know it may sound scary. You might think, oh, security architecture, that must be super complicated, lots of code, lots of servers. It's really not. When you think of the term architecture, the first thing I want you to think of is a plan. Now, when you build a house, you don't just start building the house without having a plan. A plan is like a blueprint. It's showing you kind of like a diagram saying, okay, we're going to build the house here. It's going to be these measurements. It's going to need these specific poles, these specific foundations. That is what architecture is in the sense of cybersecurity. In short, it is just a plan. I'll dig into exactly what that means later on. Same thing with infrastructure, because if architecture is a plan, infrastructure is the material. It's the hardware, it's the software, it's the connection points that make the entire infrastructure. Now, we're going to stick with the concept of building a house because that's one of the easiest ways to conceptualize a security architecture and conceptualize the actual tools required to build said house. Except in this case, it's going to be about the cybersecurity infrastructure. So, what do we want to get out of this? Well, we want to make sure that you understand what security architecture means and what security infrastructure means. The reason why is because when you get into the real world, they're going to ask you questions of, oh, what security infrastructures are you familiar with? What security architectures are you familiar with? There are going to be different models that we're going to work with. When it comes to security infrastructure, it also aligns with the concept of aligns with the concept of networking. Now, a lot of cybersecurity, you can argue, is centered around networking. The reason why is because networking is foundational in how to make different computers talk to each other. If you think about the cybersecurity industry or technology in general, the very basic concept is two systems talking to each other. It can be as simple as one person telling a system, give me an Excel document of everyone who bought a product today. That server or that product gives that information. So it's just an exchange of information. That exchange of information needs to have an infrastructure in order to function. To build that infrastructure or to build those those devices, you need to have a plan in order to do that. So this class here is a foundational concept of cybersecurity, so you can understand how you design an infrastructure, what do you need to implement, and then we'll talk a bit more about how do you make it resilient. The entire concept here is building an IT stack from the ground up. When you build it from the ground up, well, then you're able to input specific security controls, like we talked about last class, that render it more secure and give you a better security posture. So that's what we're going to focus on today. That being said, let's go ahead and chat about definitions. So when we're talking about security, cybersecurity architecture and infrastructure, like I said, to kind of distill the definition, security architecture is the plan. It's literally the blueprint that is meant to put it into place. So if you think about building a house, like I said, you need to have a plan in place to know where are we building the house? What is the house being made of? What is the shape of the house? Does the house have a garage? How many bedrooms does it have? The same thing has to happen with cybersecurity. You need to have an overall design of the system. You also need to understand like where the different parts will fit, how those different systems are going to interact securely. So that entire process revolves understanding what is the goal of our blueprint? What is the goal of our architecture? What's the goal of our system? Are we trying to be a backbone for a specific website or specific application? Are we a SaaS company? Do we need to have backups on backups on backups? We'll talk about that when we talk about security operations. Um, do we need, what is the most important piece of our business? What do we need to protect the most? These are all questions that come into play when you're trying to build a cybersecurity architecture. Let's say, for example, that everyone sitting here is part of a company. We're a brand new company and we are a startup. We just moved to a new office, and so we need to build a cybersecurity infrastructure. The first thing we do is we build a cybersecurity architecture. That means someone draws out, typically in some sort of software you can visually see. They draw it, okay, these are our main server. This is our main server with our product. This is our main server where we store data, and this is our web server where clients can access our website and then it connects the application and whatnot. If we have that, we know it's important, well, then we can design everything else. We can say, all right, we're going to have 20 employees, so we need to have a router here, we need to have a switch here. We need to do network segmentation on each of those per department. As a reminder, network segmentation is just putting some basic employees on a specific lane or a specific bucket. That way, if there's an incident, only that specific group will be impacted and not everyone else, okay? So architecture is just a blueprint slash a plan. Then the other piece is the infrastructure. Now, if we're thinking infrastructure, the first thing that should come to mind is the tools and materials. If the architecture or the plan is like a design or a document where you see what you're going to be implementing, well, the infrastructure are the actual tools, it's the system, it's the actual stuff that you're going to build. In the case of building a house, it would be cement, it would be the woodwork, it would be cabinets, fridges, it could be the paint. Those are all the materials. But if we switch that into the cybersecurity or technology space, it would be specific servers, it would be firewalls, it would be different software, different tools, different networks. These are all different technological devices that are going to be used for overall build. Thank you to all of you who sent me those messages about me teaching. That warms my heart. That makes me very happy. Um, okay, let me just check here. Okay. All right. So, if you were able to take anything from here, it would be to understand that architecture is the blueprint and the plan. Infrastructure is materials, it's the stuff, it's the actual items used, tools and materials in order to build out that system. Now, something else to keep in mind, and something that will probably be in the Kahoot later today, is the purpose of building out cybersecurity architecture and infrastructure. The number one rule for cybersecurity is to protect human life. That's the number one rule. We're talking about this cybersecurity architecture and infrastructure. Well, then its main goal is to protect the confidentiality, integrity, and availability of information. As a reminder, this means we want to protect the data so that only those people who need to see it can see it. We want to make sure that data does not get changed. And then we also want to make sure that all of our systems and servers need to be available. Now, the availability piece is really important because this is how we make sure that our business can continue running. We will talk a bit more about resilience and disaster recovery, incident response later on. But architecture and infrastructure are key because then you're proactively building all of this with security in mind. The opposite of this would be, for example, let's say during COVID, there were some companies that moved everything to the cloud, but they didn't plan it properly. They didn't have the correct architecture and they didn't have the right infrastructure. So since they didn't plan it well, a year later, they experienced a breach because they didn't have all the right security controls. That would be the opposite if you don't plan everything correctly and if you don't put everything, all of the right security controls in place. So this is one of the big reasons why we want to make sure that we have the right architecture and infrastructure. Now, when we're talking about architecture and infrastructure, this is all very device focused. It's all very like technological and hard focus, right? Like hard component focus. However, you should understand that it's not just that. Har- When it comes to the infrastructure, it can also be cloud servers. It can be certain environments like SaaS or anything that's not something you can touch. You have to keep that in mind when you build out the architecture and say, hey, anytime anyone is accessing data, well, then it goes through this process flow so that we make sure that the data is not changed and it's handled properly. So that's all logical. It's not something that you can touch, but it's something that you can visually see and understand. Okay? So let's kind of break it down a bit more. Now, when we're talking about secure architecture from the start, right? It should keep in mind that it's not something that you need to do later. It should be something that you build in from day one, meaning that you start out with the idea of secure infrastructure in mind. This is called security by design. That means building an entire system, an entire platform, an entire software that is meant to be secure from the get-go. More often than not, if you're an engineer, you will build something, but that something will be focused on the actual task at hand. It'll focus on, let's say you build a software that is able to create sales documents really easily, right? So you'll focus on, okay, we need to make sure that it does it in one click. We need to make sure that it builds out the information, pulls out the contact information, all of that, right? Which is your job. That is your goal. However, you should also keep in mind that you need to do all of this securely. That means if you're processing client data, where are you storing that data? Is that data encrypted? Who has access to that data? Is that data public facing? All of these are questions you need to keep in mind when it comes to security by design. Now, security by design, it's still focused on the CIA triad. As a reminder, it's focused on confidentiality, integrity, and availability. You will hear this time and time again in class because it is literally the cornerstone of cybersecurity. Everyone in the cybersecurity industry understands the CIA triad, so you should too. If you haven't memorized it yet, it's something that I highly suggest you do now. Okay? So, why do we want to do this proactive approach? Well, it's multifaceted. So one of the first reasons is when you take the proactive measures to secure your infrastructure, well, then you're saving yourself time and money. When I say time and money, anytime there is a security breach or anytime there's an issue, well, then if you don't have the right things in place, well, then it becomes a lot harder to retroactively fix it. So you need to make sure your initial design and your organization has all of this documented and set in place. The other piece is enhanced resilience. So that just means that when an incident does happen, because you have the right infrastructure, well, then you can easily mitigate it. So an example is like I used web servers in the past. If you have a web server and then it gets a defacement attack, meaning that someone hacks into your web server and they change your website to say something like, I hate kittens or something like that, right? Which we all know that's impossible. So we want to make sure to protect that. So there is a backup web server. That is called resilience when you have a backup on a backup that you can revert to if there were to have an incident. Then there's mitigating risks. So that means just making sure that If you have a risk, well, then you can easily spot it with your infrastructure and documentation, because when it comes to risk, it's not trying to prevent the risk, and it could be to prevent the risk entirely, but mainly it's to reduce the likelihood of that happening. Now, that being said, if you're interested in risk management as a career, well, then you might want to look into this a bit more. We'll talk about that in a couple other classes. Then there's also compliance. There are a bunch of compliance standards out there that require you to have a data map. So where all of your data lives, as well as security architecture or infrastructure architecture map, meaning that you know exactly where all of your data lives. Another piece is you want to foster trust. So when you have a security architecture, well, then you can build trust with your customers. A piece of that is if you have this and you get audited, well, then the auditor says, hey, can you show me your security architecture? You say, yep, it's right here. This is how everything works. You send it to them. That makes sure you're compliant. When you're compliant, it builds trust. I think this kind of summarizes. So let's move on. We have some questions. Do they update the backup on a daily basis in a company? So Abdul, that's a great question. So it depends on the organization. If you're asking like, do they update the backup on a daily basis? Some organizations update it daily, some of them update it weekly, some of them update it monthly or daily. Some of them update it per hour. Now, it depends on you and your organization and your risk appetite. More often than not, it is required if you want to be compliant to at least be updating it daily. There are different ways to do backups and updates. Sometimes there's a backup where you just back up everything that has changed, or you back up everything entirely. Keep in mind, there's also the concept of cost. Every time you do a backup, it takes up a lot of space, which takes up a lot of money. So it depends on the company's budget. More often than not, though, the good companies will do a lot of backups. After secure architecture, how much risk possible? Describe in percentage. I think what you're asking, Wajia, is after you have a secure architecture, how how is your risk impacted? I can't give you a direct percentage, but I can tell you that it lowers the likelihood of an incident happening. Not just that, but with secure architecture, that also means that the likelihood of an incident happening will be lower and the impact because secure architecture includes network segmentation. As I mentioned before, that means that the impact radius of an incident would actually stay pretty minute. It would be pretty small. Would you be able to rebuild an existing security architecture like doing a renovation for your home? That is a very good question, Peter. So if you have a security infrastructure and you want to rebuild the whole thing or change it, it should be possible, especially if it's all online. Now, a lot of companies nowadays are moving towards an online infrastructure like AWS, where they don't have physical servers, they don't have physical routers, but it's all logical, meaning they're using an external service to host their entire infrastructure. Now, this is good because then it becomes really easily adjustable. So just like how you remodel or renovate your home, you can remodel or renovate your entire infrastructure. Now, you do have to be careful because typically that involves working with live data, which is why you have what we call a QA environment. That stands for quality assurance. You build the entire infrastructure in that QA environment, and then you move it over to what we call production. Production is where you have all the live data, all the live servers and whatnot. Very good question. Short answer is yes, you should be able to. It can be a little complicated depending on what organization you're with. All right, let's move on. So now let's talk a little bit more about infrastructure as code. So that stands for IAC, infrastructure as code. If you've never seen this before, I'll break it down. IACs, it means managing your tech infrastructure. So like your servers, your networks and whatnot, except instead of going into each of the devices and managing them, you're using scripts and code. Let me explain. When you have a network, You have a router. You have a router, you have a switch, you have your end devices. These are all physical devices, right? And each of these devices, if you're a network engineer, you have to go into each of them and configure them. Make sure they have the right IP addresses, make sure they have the right rules to allow or disallow traffic, make sure that they're set up properly to be secure. Imagine you, as a network engineer, has to go in, because it's what they did back in the day, and manually configure each of these devices. That takes a lot of time. Well, now we've come to an age where infrastructure as code can be done, can be done where you have specific scripts or configuration files that can be dynamically sent to these devices. This means that they automatically update and are configured according to certain metrics or certain things that you desire. Think of it as, instead of clicking buttons to create systems, you can write instructions in a file. And then when you have that file, you can deliver it to all the devices so that they automatically ingest it. This is just a way to automatically update all of your devices without needing to manually take time to do that. Now, why is that important? Well, for one, it's automated. When it's automated, that means that there's less possibility for human error. As a reminder, the weakest link in cybersecurity is human error. There have been so many times where I've seen some network configurations be, I would say, be inefficient because they were improperly updated. Something as simple as a wrong IP address, one number off, or a wrong subnet could make it very difficult for the entire network to work, depending on which one you're working with. When it's automated, well, then you can automatically send a file to a specific group and cluster, and it will automatically update everything. This is why it's not just automation that's powerful, but also scalability. That means that it's able to essentially update everything on demand. You don't have to do a lot of extra pull through, a lot of work in order to make it happen. It's just fast and it's very, very efficient. Another reason why infrastructure as code is important is because it does promote security best practices. That means that you're using all of the most efficient, most secure ways to update it, as well as the most impactful way to do that. Last one is compliance. So there are some compliance standards out there that say, hey, we need to make sure that you're able to update everything quickly. There are organizations out there that have platforms that automatically update all of their end user computers, all of their network devices automatically and within a certain number of time. Because in order to stay compliant, you need to make sure that you're adhering to those. I see some questions here. It saves your data into two different locations in case one is compromised. They have a backup. Yep, Karina, that is called resilience or resilience and redundancy. AWS does that. How does cloud security architecture differ from on-prem security? Very good question to Wedros. So when you think of cloud security, right? Anytime anyone mentions the cloud, they think of like that little bubble in the sky, and we don't know how that works, right? I can tell you right now and break it down. Cloud is just another server. It's just another physical computer that exists far away. That's all it is. So when you have that computer that's far away, you need to be connected to the internet in order to reach it, in order for it to work. On premises just means that the computer and the server is in your physical location. You can physically touch that computer. That's all it means, okay? And so the difference is they do the same thing, but one of them you can physically touch and you can physically interact with. The other one is somewhere in California or Canada or New York or something like that. That's the only difference. They still do the same thing. Can you please explain this between network segmentation and network segmentation, network segregation? I could go on that for a while. So one of the TAs, I'll let you guys, one of you take that. If there's an alert system, yes, there is an alert system if the backup fails. There should be, anyways. Would having an online infrastructure like AWS be more exposed to risk, or is it better to have a physical one? Erica, you're asking the good questions. So it depends which security resource you speak to. Personally, I believe that everything is moving towards cloud right now. And so that is a lot more scalable. It's a lot more, I would argue it would be more secure because you have a lot more a lot more controls. A lot of these places that store your data, they have to have a lot of controls in order for it to be secure. That being said, if you are not using cloud, and if you're not using AWS, that gives you a lot more control. What I mean by that is you can't control if AWS goes down. You can't control if AWS goes out of business. If you have everything on-prem and you're not using an online infrastructure, well, then you control everything. It takes a lot more work and you have to do a lot more things. However, it does have an higher element of control. Terraform is cross-platform. Is it same for AWS CloudFormation? Mustafa, very good question. I don't know. I'll let one of the TAs do a bit more research on that. Don't know that one off the top of my head. Moving on here. So serverless computing, what does that mean? Serverless computing, it's when developers don't manage their server. They just write the code and then the cloud provider runs it automatically in events. So sometimes when you write code, well then you need to deploy it, you need to host it, you need to do everything for it, right? When you're working with cloud, essentially that's not the case. Developers don't have to essentially manage those servers. They just write the code, send it to the server to the cloud, and then the cloud deploys it when needed. Okay? That's all serverless means. So examples of this, Azure does it, AWS does it, and then there's also Google Cloud. They also do it. So the entire idea here is that it's less manual work and manual labor needed for the developer. They just write the code and then they send it out. Okay. Now, one of the key things to understand here is this is called function as a service, so FaaS. You won't see this very often. It's not often that you come across this, but it's essentially where you break down the functions into smaller little bits, and then you use it to actually send out to the events. I wouldn't want you all to like fixate on this piece. Just understand that serverless computing is you write code, you send it, and then the servers or the cloud actually do the actual management. Okay. Now, from a security perspective, the reason why we have to keep this in mind is you have less visibility and control over the infrastructure. So, who was it? I think it was Erica who asked about, hey, do you have a lower risk? Like this is what I mean when I say it's more scalable. However, you have less visibility and control. You can't see where exactly that information is going, and you have to trust that online infrastructure that they're actually storing your data securely. So this is why security audits exist, so that you know exactly where your data is going. Um, Now, the other piece to keep in mind here is that when you're using cloud services, you have to rely on their security model and their security infrastructure. Let's put this into perspective. You're a company, you have a product, but you're using a third party, a cloud provider, in order to process some of your data. Why are you doing this? Because it's cheaper. You don't want to buy all the servers, hire all the people to manage them. You instead want to outsource it. But when you do that, you're giving trust to that third party that they're going to process your information securely, that they are going to that they have the right infrastructure in place to not get a breach, that they're adhering to all of their correct security controls. Okay. So these are all the ways that you are giving risk to that third party. Richard asks Richard asks who regulates data protection stored in the cloud. Very good question. So there are a bunch of the different institutions that exist out there. For one of them is called ISACA. So ISACA is an association that is on IT governance. So IT governance is essentially anything around IT infrastructure, IT access control and data and whatnot. So they're one of the entities that comes to mind when it comes to overall governance. They are one of the people that put out different certifications like CISSA. So there's that. There's also GDPR. So in case you were familiar, GDPR stands for the General Data Protection Regulation. Now, data protection in general can be its own entire class, its own entire industry, because some people become data privacy specialists because they focus mainly on that. It is very legal driven, it is very law intensive, and so you do need to be familiar with law. But when it comes to data protection, it is being regulated by multiple different entities. Very great question. All right, let's continue on. So the next one is microservice infrastructure. Now, you might be asking, okay, what's microservice infrastructure? In short, it's a small independent services rather, that work together to make up a whole application. So if you think of an application, right? An application can be, let's say it's just one server that does one specific task, right? Let's go back to our example of you create sales documents, right? So if I'm a salesperson and I'm speaking to a client, the client says, okay, I like what you're saying. I'm ready to sign right now. Well, then I can just do 2 clicks on my iPad. It pulls up all the information of that client and I say, all right, go ahead and sign here. That the reason why I know this is because I used to work for a company like that, and they were really great. It's very, very useful. Now, that entire functionality to be able to just do that very quickly takes a lot of effort. So when we're talking about microservices, the service in question is creating a document that is able to pull in customer information and then make it like personable and dynamic, and then show it to the client, and then the client hits I accept and they sign, and then it goes back to our backend infrastructure. Now, when this happens, the application has multiple services. All of those services could be built in-house. That means that we build the code, we put it together, we host the servers, we host the data. Okay, that's if it's just one big massive service. If it's a microservice, that means that it could be multiple different services in and of itself. So the one big service or the one big system, that would be called like a monolith, like just one big massive thing. Whereas a microservice can be, hey, we're going to store the client data, but there's this other service, this other independent service that processes the data. There's this other service that builds the document. There's this other service that actually does the signing certificate to make sure that it's authenticated and that it's actually signed properly. These are microservices that come together to build this system. A microservice is just small independent services. They can be software, they can be companies, they can be just like different entities that all have the same goal of producing a software or producing an end product. So a microservice, an example could be it runs code or it stores data. Maybe it's the one that deploys the information or updates it independently, or maybe it's a microservice that communicates with an API. Okay. Now, if you don't know what an API is, just a quick reminder, an API stands for Application Protocol Interface. Anytime, if I have my mouse, anytime I go up here and I click anything, well, then it does a specific action, right? So in the same way, an API in very rudimentary terms is the computer speaking computer language to another computer telling it to do something. Keep in mind, APIs are very, very powerful. It's essentially giving you the keys to the kingdom. If you have API credentials, you can tell any computer to do anything if it doesn't have the right safeguards. So APIs are really important to protect. APIs are kind of like a waiter taking your order and delivering it. I think that's a good example. So think of an API as, okay, if you're, let's say, an unethical waiter, well, then the client or the customer says, "Hey, I would like a steak." And you're like, "Okay, great." But when you take it to the kitchen, you mark it down as two steaks so that you get a bigger tip or you get a higher percentage, right? That's something that you could do with an API, just as an example. All right. So some key points here is uh, when it comes to microservices infrastructure, you need to keep in mind that they have, since they're smaller, well, then they're not as well, they may not be as well connected, and you're still relying on all of those different teams. Okay. Now, the good thing is that since they work independently, well, then you kind of have a lot more control over them. More often than not, microservices tend to be smaller companies. And so if you're a big company, you have a lot more, you have a lot more control over telling them, hey, we want you to build this, yada, yada. They're scalable because you can build them up to scale. Fault isolation, you don't have to worry about that. Security challenges. Now, one of the things you need to keep in mind here is that when you have a bunch of different microservices, right, that means there are more endpoints. Each of these microservices in and of themselves is an attack surface, meaning that if they have an attack, then that might impact your overall server or overall functionality. If you have different microservices and they're sending information to you, you need to make sure that you authenticate and authorize each one of those, right? So if you do that, well, then you need to make sure that correct access control is set in place. And of course, since you're doing a lot of transfer of data, you need to make sure that you have encryption set at all points. Okay? Yes, Alex, an API can be a potential attack surface. That can be. That would take a while for us to go into, though. All right. Time for you all to practice writing in the thread. Quiz thread. A, B, C, or D. How does infrastructure as code enhance security in IT environments? A, B, C, or D? All right. Everyone says A. Great job. That is correct. Well done. All right. Now let's talk about cloud computing. Cloud computing Cloud computing is an interesting word because when people think of cloud computing, they think complexity. They think, oh wow, cloud computing is so advanced, right? It's really not. Cloud computing, in very simple terms, is just using remote servers, like AWS is one of the most common ones. The three big ones that you should know for cloud computing is AWS, Microsoft Azure, and Google Cloud. Cloud computing is just storing and processing data. That's it. Cloud computing is just storing and processing data. Now, the opposite of cloud computing is doing a local infrastructure, which is the on-prem that we were talking about before, meaning that instead of me sending my data to AWS or Google, well, then I have my own server right here that I can use to process data. So why is this important? Why do we need this? Well, in very simple terms, if you're using cloud computing, you don't have to manage your own hardware. You don't have to buy an actual server and manage it and use it. You don't have to pay additional electricity for it or pay for storage or services. Instead, you rent it. It's like it's like you rent a computer far away to process all your data. Why is this important? Well, for one, it's flexible and it's scalable. These companies, AWS, Azure, and GCP, that stands for um, uh, Google Cloud Platform. So all of these, they specialize in storing and processing your data. You might be asking, well, why do I need to process data? What does processing data mean? You remember that example I told you about turning the iPad around and then the client just signing their name? to like work with you? Well, as you can imagine, there's a lot of data that needs to be processed. One example is if you're working with a client, you need to have that client's name, their company name, what services they're interested in. This is all data. That data needs to be processed and stored and able to be transmitted back to the iPad to show it correctly. That's the entire idea with data processing. Okay. So these companies like specialize in that, which is why it's very flexible and efficient. Another reason is it's cost effective because then you don't have to manage anything on your own. And all of these companies have really, really good security. More often than not, they have a lot more redundancy. Redundancy, again, is if one server fails, another one takes over. Okay? Now, those are all the benefits. Those are all good things. However, there are some security things to keep in mind. For one, you have to trust the provider and its security infrastructure. That provider needs to have all the correct security controls set in place. Now, Amazon and Google and Microsoft, they're all known to be pretty secure, but that doesn't mean that they can't be hacked. That doesn't mean that they can't have any sort of issue. Okay. That being said, even though you're following their security infrastructure and you're trusting them, keep in mind that you are in charge of your data. Just because you're handing your data over to a third party does not mean that you are not in charge of your data. You have to be the one to secure the data, secure your apps, make sure that you have what we call data hygiene, that you're not putting garbage data into those servers. Instead, you're putting high quality data in there. And then the thing with cloud computing is you need to have the correct access control, you need to have encryption, and then you need to make sure that there are the right configurations set in place. Okay? So if you're going to remember anything from cloud computing, just remember that the big three, Amazon, GCP, and Microsoft, all they do is they store and they process data. That's all they do. Okay? It's a lot easier and cheaper to do it that way as opposed to storing and processing all your data in your kitchen or in your home. All right, now let's talk a little bit more about security matrices. What does that mean? Or sorry, responsibility matrix. What does that mean? A responsibility matrix is essentially a chart and it outlines all of the security tasks that all of the different devices do. A very simple example is a job board. So if you've ever worked in a kitchen or if you've ever worked in a line, I used to work in cafeteria when I was in college. They had this sheet that showed where everyone was. Sometimes someone would be on the grill, sometimes someone would be serving people, and it all just like depended, right? That's kind of like the responsibility matrix. It's just a chart that shows who does what. Typically, it's what we call a shared responsibility model, okay? Now, you do have to decide who is responsible for what, depending on what you have on your team, right? So you have the cloud service provider, the CSP, and the customer. Now, with these two entities being the people that we want to keep in mind, they each have different responsibilities. For example, the cloud provider, their responsibility is to handle data. They have to handle data security. They have to be the ones to have the physical hardware. They have to have all the networking. The cloud service provider is one that controls all of these. Whereas the customer handles the actual data itself. They handle maybe user accounts, and then they handle the actual application. So keep in mind, the cloud service provider, they just store the data and they process the data. That's all they do. The customer, us in this case, we're in charge of the actual application itself. Now, what happens here is we need to make sure that we have a direct and clear visibility into who does what and who's in charge of what. Typically, this will come in the form of an SLA, so a service level agreement that says, hey, you're in charge of these security measures, we're in charge of this. And you state it out directly. This is typically signed by leadership to make sure, and it can be legally used to say, hey, Mr. Cloud Service Provider, you did not store our data properly and we got hacked. This is where you said you would have all the correct security features. You didn't, so we need to have a discussion about financial compensation. Okay. All the responsibility matrix does is it highlights who's in charge of what. That's all it does. Okay. All right. Let's move on here. Now, there is, we talked about cloud infrastructure, right? We talked about putting everything in the cloud and making sure that we have it all listed there and it's cost efficient and whatnot. Then we talked about on-prem. On-premises meaning that you have it in your home, you can touch it, you're the one who actually handles all of it, okay? In this case, if you're a business, you have it in your office. There is something called a hybrid approach. So a hybrid approach is a combination of both, where sometimes you're using your in-house servers and sometimes you're using a cloud server. It just depends. Now, most companies, they're more often than not they're not 100% on-prem and 100% on cloud. Instead, they're typically a combination of both. So if I were to define this in very simple terms, I would say that you use your local servers, your local firewalls, and your internal apps. And then you also use cloud services. So you're using like different storage applications, different hosting apps, different data centers, and whatnot. Okay. So those are the reason why I bring this up is because you remember when I mentioned meaning combination is better. Yes, very good, very astute. That is correct. When you have your own on-prem server, you have a lot more control. Companies like control. They like controlling their data. They like controlling how it's being processed. They like having that control, right? And then they also want to outsource some of the more menial tasks. They want to outsource a lot of the things that are a lot more tech heavy and that may be more expensive. Okay. Now, in this case, there needs to be really good integration. There needs to be a lot of data hygiene and data cleanliness, because if you're working with both on-prem and cloud, you need to make sure that it's garbage in, garbage out. You need to make sure there are all the right security measures in place for both. Okay. Let's see here. So you need to make sure it's encrypted. Okay. All right. Now, what is the biggest thing here? A big consideration to have with hybrid cloud environments is visibility. What does that mean? You can't protect what you can't see. So if you have on-prem infrastructure, more often than not, you might keep your data, or at least partially some of your data in one location because you have visibility into it, but you send out any data that's not exactly like quote unquote sensitive to be parsed and processed. Okay. So you need to have security tools that look into both. Okay, I think we touched on that. All right. I think one of the last slides we'll touch on is third-party vendors. So what is a third-party vendor? So a third-party vendor is essentially when a company hires outside services in order to accomplish a specific task. So this is like payroll provider or software vendors, something like that. A very simple example of a third-party vendor is a job board. So if you're trying to hire someone, instead of posting it on your personal website, you can hire a third-party vendor that specializes in job boards and say, hey, can you please put this out there and get me a bunch of candidates? And then whoever you think are like the top three, we'll go ahead and interview. That's like a third party when you're using a third party. Now, in this case, we're talking about third party to manage your cloud services or manage your security services and whatnot, right? Now, when you are working with a third party vendor, you need to do a third party due diligence. That's why there exists an entire industry called TPRM, which stands for Third-Party Risk Management. Now, third-party risk management is important. It's a whole entire industry where you can make this your entire job because you want to identify any risks ahead of time before you actually work with them. This is why due diligence is really important because you need to make sure that they have the right security controls, the right security practices, the right certifications, and that they comply with all industry standards. Typically, this third-party vendor would be through a process like a form of some sort. And that form would be filled out by the third-party vendor saying, yes, we have access control. Yes, we have network segmentation. No, we don't send your company data to our own third parties. And no, we don't process it unsecurely. And then there's contractual agreement. So you need to make sure that you have a responsibility matrix in there that outlines everything specifically. And then you need to make sure that you have the right access control, that you do regular reviews of that access control. So that's why the ongoing monitoring is a thing. When we do regular reviews, well, then we know what data is going in there, what data is not, because keep in mind, the principle of least privilege still applies here, meaning that we don't have to give a third party all of our data. We can give them just a little bit of our data or just what is needed. For example, if you're working with a company that is outsourcing their hiring process, well, then they don't need to know all the company numbers. They don't even need to know the company code. They just need to know what the job description is and maybe the contact info of the hiring manager. Of course, you need to make sure that you have the right contracts, SLAs, access control, shared credentials, whatnot. We'll talk a little bit more about incident response planning later on, but for a third party, you need to make sure that they have a good incident response plan and that they address it accordingly, that they address it securely. Third party nowadays globally means to say it's not in the home country. So security another concern, like due diligence. Yes, very good thought. Yes, typically third parties means outsourcing it to another country, more often than not because it's cheaper. So there are security measures that come into play there. Chukwudi, I see your hand is up. Just go ahead and put your question in the chat, and then one of the TAs will be able to answer it. So you do need to make sure, that's why due diligence comes into play. You need to make sure that they have all the right security controls. If you are sending data across country lines or into another country, you need to know if there are certain laws that you need to adhere to. If the clients in your country need to be aware that your data is being processed in another country. More often than not, it's just by saying, hey, in our privacy policy, it says by giving us your data, you are consenting to us sending it overseas to our third parties. Can third-party vendors also be a cause of major risk or security compliance? 150%. Wajiha, 150%. That's why third-party risk management exists. It's to protect you and the company. If the third party is somehow not having the right security infrastructure and the right measures in place, well then yes, they can be a tremendous source. All right, it is 1 minute past, so okay. All right. So we did talk about third-party vendors, right? And like I mentioned, TPRM is a whole role in and of itself. So if you're interested in that, I would suggest you take a look at it. It's a good job. Um, it's needed. And if you're working for a big organization, it'll come very much in handy. All right. Now let's shift a little bit of our focus into network infrastructure. So like I mentioned before, cybersecurity does have a backbone in networking. Like I said, networking and just cybersecurity in general is just two entities, typically two computers, or maybe it's a human and a computer or a server, trying to send information to each other. The way this is done is through a network of devices that connect those two entities. Now, with those two entities communicating with each other, obviously you need to make sure you have specific IT infrastructure in order to make sure that works. As a reminder, infrastructure is the materials. It's the actual things that you implement in order to make it secure and work. Now, when we're talking about the devices for a network, there's things such as routers, switches, firewalls, servers, and cables. If you've never been exposed to networking before, don't worry, we'll break it down. Now, we get to have Mr. Picasso, Andre, draw us some pictures. Now, when I draw these pictures, keep in mind, everyone, these are going to become very valuable in the future. So if you take pictures and screenshot them, you could probably send them for $1 million in like 20 years. Now, if we have a network, right, we always start the network with the end computer. So let's say this is Zainab's computer. Fancy keyboard. This is their work computer, right? And then their work computer needs to connect to the internet. So we have a router. This router connects to the internet. This is a cloud that represents the internet, okay? Now, the router is what connects to the internet, and typically you'll have a firewall here, which disallows traffic from getting into the network that could be malicious. And then sometimes you'll have another firewall here, because now that it's entering the internal network, well, then you need to protect data from coming in. So here, after it gets that firewall, it gets to a switch. So a switch is a device that routes traffic based off specific criteria. So here you have Zainab's device. Here you have Mary's device, but Mary's on a different team. And then here you may have a web server. And then here you have a data server. Okay, so these are all of the different servers that exist on your network, right? So keep in mind, Mary and Zainab are on two different teams, which means that they're going to be network segmented. So this switch says, hey, in order for these to communicate to each other, they all have to go through me. So if Zainab wants to reach the, we'll call this web. If Zainab wants to reach the web server, they have to first go into the switch, and then the switch says, are you allowed to reach the web server? Yeah, you are. Great. And then if Zainab wants to reach the data server, well, then they'll go to Z and then M. So they'll go to the switch. They'll say, do you want to reach the data server? I'm sorry, you don't have access to it because we have access control in place. Okay. When we're talking about networking, we're talking about these devices, the firewall, the router, the switch, and then the end devices. So network infrastructure is just making sure that you have all of these devices set up in such a way that it's as secure as possible. This is why we have something called physical isolation. So making sure to isolate Zainab from Mary's computer, or isolate the web or the data from each other. Because if you have, it's like if you have all the computers in one place, if one of them gets compromised, all of them can get compromised, right? Air gap systems, this is when you have like a bunch of different, a cluster or a server rack of servers. Logical segmentation we talked about. And then software defined networking, that's an SDN, right? So a software defined networking is when you put a specific software in a specific zone per se, because it's meant to only be used by that software. Okay. That's a very get into this a bit more, but when we're talking about networking, this is what we mean. Now, there are a bunch of layers to this. For those of you who are familiar with the OSI model, this is what we would go into at this point, but we'll talk about that later on in class. But these are all of the networking tools that are used to safeguard the network as a whole. So what we're going to do is we're going to dive into each of these, okay? All right. Last chance to take a picture of this before you can sell it for $1 million in 20 years. Okay. So we are done annotating. So now let's talk about physical isolation. So this is a perfect image for that. Physical isolation is essentially separating sensitive information, like physically separating sensitive information. So the reason why this is important is because A, it's one of the oldest and most effective ways to be secure. You're physically separating two specific devices, meaning that they're completely separate. They don't share any cables, Wi-Fi, or internet. That means that they can't fully be connected to each other, okay? Sometimes when you hear the term physical isolation, that can also be defined as air-gapped, meaning there is a gap between the two devices and they cannot connect to each other. So you might be saying, okay, well, I understand the concept of air gapping or physical isolation, but I'm starting to wonder why. Why is that important? Well, when you isolate, you're essentially preventing sensitive information from being accidentally or intentionally leaked. Because they're not connected, well, they can't accidentally or intentionally leak to one another. What this does, it reduces the risk of that leak being happening, as well as reduces the ability of malware to spread. This is a form of segmentation in a sense, because you're segmenting each of these devices from each other, separated by air. Can multiple servers be physically isolated? Yes, multiple servers can be physically isolated. Okay. Now, when you do physical isolation, you're essentially taking a protective measure against yourself, right? That being said, however, there are some things you need to keep in mind. Because you're not connecting them with wires or anything else, well, then you have to remember that it is going to be expensive to maintain. You remember how we talked about code that you can deploy and automatically update them. Well, since they're not connected to Wi-Fi, since they're not connected with cables, well, then you'd have to go ahead and update these devices manually, which can take a lot of time and effort, which makes it expensive. The other part is it's also harder to scale because you can't, since they're not connected to anything, well, then it's difficult to essentially like update them with everything else. That's why it's also slow. It can slow down your daily operations if you don't pay close attention. Now, mm, okay, I think we already talked on all of that. Yeah, we're good there. Okay. So we talked about air gapping or physical isolation. Now let's talk about what we call logical segmentation. So logical segmentation is essentially network segmentation. They're synonymous. They're the same thing. Are they isolated from the internet? Would you have to use USB to update? Yes, Brandon, that is correct. They are isolated from the internet and you would need to use a USB to update it. Very good observation. If you're wanting to better understand it, how can we access data from the air gap system? So Lee Kuo, I love this question. You have to physically go to that server or go to that data and grab it from yourself. So more often than not, a lot of air gap systems and servers tend to be data servers. Sometimes they'll be very sensitive data servers, such as they're storing proprietary company information. Maybe they're storing some designs of certain military aircrafts or something like that. And the only way you can access it is if you physically walk into that server room and then connect with a wire to your computer and have access to the information. Now, obviously, this becomes difficult to update the information that lives there, But more often than not, this tends to be not be like a huge issue for a lot of people because of the money. See a sign in the movie The Amateur has that, right? Um, I'm trying to remember if there was a scene from that because I saw it recently. I think so. Yeah, I think so. I don't remember off the top of my head, but the concept is correct. All right, let's move on to logical segmentation. Now, like I mentioned, logical segmentation is synonymous with the term network segmentation. Anytime I talk about network segmentation, this is what we mean. It's essentially the version of isolation where you separate the systems and divide them into different buckets or different networks using specific rules. Like I mentioned before, this can be done by department. Sales has their own network, and then marketing has their own network and whatnot. Now, the logical networks that we're talking about here are broken down in what you call VLANs. VLAN stands for Virtual Local Area Network. It's essentially a group of systems that are grouped together based off of their role. It is not based off their physical location. This is why you can still be on a specific VLAN but work remotely. If you're on the sales team and you're in New York, well, you still can't access any of the marketing admin tools because you're not on that VLAN. There are specific rules and policies that are in place that prevent anyone from jumping to another network. Now, keep in mind, there is also something called micro-segmentation. Micro-segmentation is if you take that department and you have it on its own VLAN, and then you break it down even further into smaller sub-network sections. It would be, for example, if you're unfamiliar with the sales team, typically they have the sales director, then they have a team lead, then they have what they call an enterprise account executive and then account executive. These are the people that sell to like the big wigs that have a lot of money. And then you have what we call an SDR. That stands for a sales development representative. They're the ones who do the cold calling to try and get leads. So if I were to do micro segmenting on a sales team, well, then I would put the SDRs on their own segment, and then I would put like the account executives on their own segment, and then directors on their own segment. This micro-segmenting allows it to say if a director were to get malware, it won't go to the rest of the sales team because it was micro-segmented. If an SDR, a sales development rep, were to get malware, well, then it wouldn't go to the rest of the sales team. The entire concept here with logical segmentation is just to use rules in order to protect the rest of the organization from external threats. Now, it's not just external threats. It can also be internal threats. We have firewalls, like I've shown you before, as well as access control lists that control traffic of who's allowed to access what segment, what system, and what server. I would call it like a protective measure from insider threats so that you can keep enforcing the principle of least privilege. Now, there also is another principle that logical segmentation helps here, which is the zero trust principle. It assumes that no system is trusted and therefore they have to verify it. That's why there are multiple segments that typically connect to a router or to a switch that essentially validates traffic that's coming to and from. Okay? Does that make sense? Logical segmentation and network segmentation, easily one of the best ways that you can protect a system. All right. And then now we have something that we call software-defined networking. So software-defined networking is essentially like it separates the control plane. So the control plane is like how the networks are managed and whatnot from the data plane. So how traffic actually moves. So there's a difference between managing your network and then the actual movement of traffic. When you have a software-defined network, it essentially is enable you to keep both of those things separated. What device do you need to use for all these segmentations? So more often than not, Kobena, the device you would use would be a switch. Now, it can be a router, it can be like different networking devices, but the more often I've seen it, it's been either a switch or through a VLAN that was able to control those. What are the security risks associated with 5G since it has more connected devices? Oh, Tawedros, that is a big one. Mary or um, Zainab, I'll let you all take that one because that we could talk about that for ages. So in short, an SDN is software-defined network. So instead of needing to configure the routers or the switches manually, like I said, you need to go into each one and kind of like update them. Well, then you can control that network via software. You can have that software update all of the routers and all the switches dynamically. This is beneficial because it can automatically update them with routing and traffic information, and it can update any segmentation needs. An example is if you get a new employee that joins the team, well, then automatically with the SDN, they will automatically be added into the right segmentation. And then if you, let's say, have a security policy, which as a reminder, a security policy is in very simple terms, right? A security policy is a set of rules that allow or disallow certain actions on a network. So if, let's say, you add a new third-party vendor that needs access to your data, the security policy can be updated and then sent to all of the network devices. When you send it to all the network devices, they say, hey, this third-party vendor has this IP address. They're trying to access this piece of data. The policy, security policy says they're allowed to access it. So let's go ahead and give them access. So if you're going to remember anything from software-defined networking, it is just that it is a control panel. It's a central control location that allows you to update information and essentially get faster responses to threats because it's centralized and you can put in real-time changes. Essentially, it's a way to send out changes to all of your network devices instead of need to update it manually. Are companies less reluctant to implement strategies nowadays, or is it still a struggle of compromise and having to really sell them on it? Let's talk about this because Ali asked a really good question. So, how do I put this in a way that doesn't make you guys lose hope? Okay. In essence, when you have a company, right, the company's goal is to make money. Their end goal is to increase their bottom line and increase profit. That's their end goal. So cybersecurity is something that's only top of mind because it would impact their finances if they didn't do it. I guarantee you that most companies, if they didn't have to, they wouldn't implement all the security controls. Why? Because sometimes those security controls can impact operations. So the short answer to your question is it depends on the company culture. There are some companies out there that do not care about cybersecurity. They don't care about what gets done. They just want the check mark so that they can keep selling the product, keep making money. They only care about security once an incident happens. Then they say, why didn't we do that? Why didn't we do that? Why we didn't do that? This is why I'm telling you all as a professional that when you become a cybersecurity professional yourself, you need to document everything. Document when a director says, I don't want to implement access control here. I don't want to do network segmentation. I don't want to do security awareness. And then document when they said it and why. Because when an incident takes place, you can point back to that and say, you told us that you didn't want to do this because of that. Then they'll have to answer to the board of directors, to the CEOs and whatnot. The reason why this is important is because when an incident does happen, people feel uncomfortable pointing at themselves. They instead start pointing fingers because they don't know what else to do. So, as a professional, you need to be prepared to say, "We didn't do this because you said you didn't want to, or we didn't implement this security strategy because you didn't want to compromise operation or sales or potential downtime. Ben is completely right. I'm not going to say what CYA stands for, but you can look that up on your own. In essence, it depends on the security culture. What role does the YubiKey play in network segmentation and access control? That's a great question. So Quibena is asking about this. So this is I don't know if you can see it. This is a YubiKey. As a reminder, a YubiKey, I'll type it here. A YubiKey is essentially like a physical two-factor authentication or multi-factor authentication. I have one and I carry it with me all the time. And this has a very specific signature on it that is only applicable to me, and only I can use it to access any of my accounts. No one else can access any of my accounts unless they physically have this. Now, the way that it plays into network segmentation, it doesn't really, but it does play into access control because this means that only the people who have my YubiKey and my password can access any of my accounts. Now, the downside to a YubiKey is that you have to never lose this, because if you lose this, you lose access to all of your systems. So this is an element of humanistic psychology and cybersecurity, meaning you can't just talk the talk. You have to walk the walk. I've had to change my lifestyle in such a way that I know where this is at all times. How do I do that? Well, I have my motorcycle keys on it and I have my headphones on it. I use my headphones all the time. So I know where these are at all times. That's how it plays into access control. Good question. You all are asking really great questions. Okay, let's move on here. Can you have a backup of a YubiKey? I'm not sure. Last I checked, I don't think so, because this has a unique string on it. And I thought about trying to find a way to copy that, but then that would defeat the purpose, wouldn't it? Because then someone else could just make a copy of your YubiKey. So no, you can't, I think, but I don't know if they've updated that since then. All right, now let's move on to architectural models. So now that you understand some of the, yeah, okay. So now that you understand a bit more about like the security infrastructure and security architecture, let's talk about the different models. So what do I mean by the different models? Now we talked about on-prem and cloud. We'll talk about the different centralized versus decentralized architectures, and we'll dig into containers and visualizations a bit more. But at a high level, an architecture is like an approach that defines how the system or the application or the data or users interacts. So application model essentially guides them on where systems are being placed, whether it's cloud or on-prem, how they communicate to each other, and how security is enforced at each layer. So the model is going to impact where it is, how it communicates, and security there within. Now, there's a common piece of knowledge that comes with architectural models. They have all the same goals. Their goal is to maintain the CIA triad. Remember that. All architectural models try to maintain the CIA triad, which stands for confidentiality, integrity, and availability. Their entire goal here, based on the different models, is to reduce the attack surface, but that is based on the goals of the business. And then it's also meant to um, create more easeability, so allow scalability and allow resilience overall. Okay? All right. So we'll kind of dig into each one of these. So the first one is on-prem versus cloud. So when we had talked in the past, right, on-prem means that if you're a business, you own your servers and you manage the physical space and control everything about those servers. So remember, when we're talking about on-prem, it's all about control. It's all about knowing where your data lives and how it's being processed, how it's working, right? The advantage of that is the overall element of control. Now, this is typically used more often than not when you're dealing with highly sensitive data. And then when you really want to restrict access, typically regulatory, if you want to be regulatory compliant. Now, this is very expensive. So I think we talked about that before. And you do need to have very specific personnel that are able to configure, update, and work with these more on-prem devices and environments. Ooh, Pedros, I see your question. I'm gonna let one of the TAs answer that because it gets a little hairy, but I think they'll be able to answer that with additional research there. Now then there's cloud environments. So cloud environments are a little different. It's like you're renting the infrastructure. You're renting the service from one of the big three. A reminder, big three is AWS, Azure, and Google. Now, this is good because it's cost effective, it's flexible, and then it's kind of its resources are pretty good at processing and storing data. And so you can essentially scale it a lot better. You can always add more space or reduce more space. It's very, very flexible. That being said, when you're using cloud infrastructure, you are giving part of the keys to your kingdom to a third party. So if they don't have the right security controls in place, well, then you kind of share that responsibility. The provider manages the infrastructure and you manage the actual data, the access, and the actual application. Keep in mind, these cloud infrastructure and cloud computing, all they do is they store the data and they process the data. You own the actual data itself, like the data hygiene, what data you're putting into it. You own access to that data and you own the application that you're using that data for. So there's that shared responsibility in the responsibility matrix that we had talked about before. Okay? Right. Now, there is two elements that we need to kind of like touch on more, which is centralized versus decentralized data architectures. So for one, centralized means that all your data and systems are managed from one central location. Okay, so you have a single point of control and it simplifies the concept of deploying policies, deploying security measures, deploying any updates. It's all done through one singular point of control. Decentralized means that your decentralized architecture, it spreads out processing and control across multiple locations and multiple different systems, meaning there's not one central location, it's pretty spread out. So let's kind of talk about the pros and cons here. When we're talking about centralized, because you have that single point of control, because you have that central location, well, it's easier to control, it's easier to manage, it's simpler to keep secure because you have that one location. That one location, you can have strict access control on that, which controls everything else in the architecture. It's also really good because it's more efficient and you don't need as many resources to keep it alive. Now, this is kind of a double-edged sword though with central architectures because as you can imagine, if you have one piece, one device that controls everything, if that device fails, well then that can be what we call a single point of failure or a bottleneck. If that one element fails, well then everything else fails, okay? So you have to keep that in mind when looking at centralized architecture. Sure, it's easier, but single point of failure. Now, the decentralized architecture is slightly different because the benefit is that it's more resilient to outages. Since a lot of the data is spread out and in a bunch of different places, well, then there's no single point of failure. And if one of the nodes goes down or one element goes down, it doesn't necessarily mean that the entire network is in jeopardy. Instead, it means that maybe that one thing can't function completely, but it means that the entire network is still available. Remember, all of these architectures are meant to do the CIA triad, confidentiality, integrity, availability. With the centralized architecture, that one point of failure could cause the loss of availability. Whereas with decentralized architecture, losing one piece doesn't mean that it would be detrimental to the entire network. It's also good because if you have a decentralized network, well, then it is better for scalability, so you can grow a bit more. And it does help for some better decision making. That being said, it is a lot harder to standardize. It allows a lot more work to keep up and secure, and it's complex to secure consistently. Okay. So those are the pros and cons of centralized and decentralized architectures. Talking about AWS team, how do we classify iCloud? I don't think I know iCloud's infrastructure on the back end. I'm going to guess it's centralized. How does centralized versus decentralized affect failover and redundancy? Good question, Dwayne. So redundancy and failover, in case you all aren't aware, that's part of what we call DRP, disaster recovery planning. If there's a disaster, well, then what do we fail over to? If there's a disaster, do we have a backup on a certain system? Now, if you have a centralized architecture and it's all being controlled by one specific location, well, then that actually, quote unquote, shouldn't fully affect failovers and redundancies because those should be able to function even if there's a central node that is quote unquote compromised. Depends on the architecture. Ideally, if you had it set up properly, well, then it should still be able to function. Now, if it's decentralized, because you have a lot more resilience, decentralized architectures tend to be a lot better when it comes to redundancy and failovers, because then if one system goes down, because you're not all controlled by one specific a single point of failure, well, then you can bounce back a lot faster. I see Mitesh's question. If by mistake you wiki breakdown, so can you get your access? Yeah, that's a good question. So Mitesh, I do want to talk about this because I know a lot of people had questions about YubiKey. Now, yes, YubiKey is one of the ways that I'm able to access all of my accounts, but it's not the only way. I have multiple different MFA tactics to get in. If I lose this or if this breaks for whatever reason, well, then I can still access my accounts either through MFA or one-time password sent to my email, to my phone, a notification. I have multiple ways I can access my accounts. This is just my preferred one because if someone tries to access my accounts from another country, they can't because they need my YubiKey. Now, the YubiKey is the first layer of defense. Now, if I don't have my YubiKey, which has happened in the past, well, then I can go ahead and have it sent to my email or have it sent to my phone. Okay, so the YubiKey is not the single point of failure. There are a couple others. Good question. All right, let us carry on here. Now let's talk about containerization and visualization. So bear with me here because I know these seem like very technical words. I'll try to break them down very simply. In very simple terms, the concept of, well, I want to break down virtualization first. So virtualization is essentially, it's working with VMs. VMs stand for virtual machines. These are full-on computers or full-on servers that don't have a physical body. That's all it means. So virtualization is where you're able to run multiple machines from a single physical server. So each VM or virtual machine is like a separate computer. A very simple explanation of this a very simple explanation of this is if I have my computer here that I'm using right now, in this computer, I say, okay, I want to be able to run Linux on this computer. It's a Mac right now, so I would have to use a virtualization to run Linux. And then if I say I also want to make another one for running Microsoft, I could use a virtualization for that. Essentially, virtualization is just allowing you to run multiple separate computers on one physical computer. That's all it is. Containerization is somewhat similar, but instead of having full-on machines, so full-on operating systems, full-on computers that are running, containers run individual applications with all of their dependencies. Okay, so that means you don't have to have a full-on computer. Instead, you have a contained application, a contained service on there. Why is that needed? Because when you have that, it's a lot faster, it's more lightweight, and it's more portable than an entire VM. Okay, the idea here is that VMs take a lot of space and whatnot because it is a full computer that's virtualized. It's a virtualized full computer. Whereas a containerization is just holding the application in and of itself. Okay, so what are some examples? An example of a containerization is something like Docker or Kubernetes. You are going to have to know these in the industry. Docker and Kubernetes. So and Kubernetes are containerizations that where you can put in an application and then you can use it to run applications or work on those applications. Now, virtualization is something such as like VMware and then hypervisor. Those are a couple of them. I also know that there are a bunch of different tools that you can use for virtualization. Tools for virtualization. So there's VirtualBox, there's Oracle. There are a bunch of different services out there that allow you to do virtualization. Now, as a reminder, virtualization is just putting a fully functioning computer on your already existing computer. That's all it is. Okay? Now, what are some advantages of these? Well, for one, if you have a containerization, it's more lightweight, it's more efficient, takes less time, it's more scalable. Um, but the container is sharing your host system's kernel. So your kernel is like your computer brain. So when you have two computers, so you have your physical computer and you have your virtualized computer. Your virtualized computer is sharing resources with your physical computer. So if you're doing this, it could be a potential vulnerability. Now, virtualization means, simply put, you have another computer on your physical device, right? So this gives you a lot of flexibility. It isolates the environment. When you're typically doing pen testing or when you're working on a specific malware, more often than not, you are using a virtual computer because if that malware starts acting up on your virtual computer, you can just disconnect it and it won't impact your actual computer. Okay? Um, when you do this, though, you need to be careful to have the right configuration set in place because if you don't and you don't have the right security measures, it is possible that whatever you're doing on that virtual computer could reach your actual physical computer. Okay? So, what are some things you should be wary of when working with containerization and virtualization? In short, isolation. Now, containers, like I said, they share the same kernel as your physical computer. So if you don't manage to isolate it and you're working with malware, well, then that malware could affect your physical computer. And then when it comes to misconfiguration. So if you don't configure any of these devices properly, well, then it could expose the APIs, which stands for Application Protocol Interface, and that could invite some attacks. Okay. In essence, you just need to make sure that you have all the right security measures in place. Okay. Yeah. So Keith asks, yes. And Mary, yep, definitely on the same page there. Typically, your VM will have its own IP address, depending on how it's configured. Okay. Now let's talk about something that's been a big topic for several years, and that is IoT devices. IoT devices stand for Internet of Things. So these are just objects that are capable of connecting to the internet. Think smart objects like a smart thermostat or medical devices or coffee machines. Now they have like Roombas and vacuums that are connected to the internet. These are all singular devices that serve one specific purpose, but they are connected to the entire internet. Okay. Now, why is this important for you to know as a cybersecurity professional? Because the security of these devices is incredibly weak. So they are not very strong at all because the whole reason why they exist is for convenience and to make things easier for people. But that being said, they care about the functionality more than they care about the security. Okay. The reason why this is because many of these devices in and of themselves use default credentials. Default credentials means when you get these devices, it has a username and password, and they typically don't get updated. Okay. That being said, that as well as the fact that they have outdated firmware. Now, the outdated firmware is kind of it's a two-way street because sometimes the manufacturer doesn't put in the effort to make sure to update them, but at the same time, it's up to the user to make sure to update them as well. Um, a lot of the time, they don't have proper encryption. Don't have basic logging. Now, this is I think someone had mentioned the movie The Amateur. I'll bring up another movie called The Accountant 2. I won't ruin it for everyone, but in The Accountant 2, I suggest everyone watch it because it's actually really interesting. There's a group of kids, they use an IoT device to get access to a woman's network and steal data from her. This is a real thing that happens in cybersecurity where they actually take the vulnerabilities in an IoT device and use it to steal information. Okay? Um, da, 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 da. So overall, IoT devices are not as secure and they should be used with caution. Now, keep that in mind because if you ever do watch The Accountant 2, it does have some really cool cybersecurity scenes in there. So, if you have an IoT device, which, by the way, an IoT device can be like a it can be like a Amazon Echo. It can be a Ring camera. It can be a Roomba. Any of these devices that do one specific thing. The first thing you need to do if you have any of these is to put them on a separate network, as in network segmentation. This is not too difficult to do. All you have to do is look up your ISP, your internet service provider, and then look up how to set up a network within a network. That, or you can reach out to them and say, hey, I want to create a network segmentation. So when you do that, you put all of your IoT devices on that network so that if they do get hacked, they can't get into the rest of your network. You also want to check your router to see what are all the devices that are connected to the internet. One of the best ways to protect yourself is just to remove that IoT device from the network in and of itself. And then you want to make sure that you have proper access control, updating the username and the default username and password, make sure only certain people have access to it. That being said, um, I know that a lot of my colleagues who I've known in the past who work in cybersecurity, none of them have an IoT devices. Some of them barely have cars and motorcycles that are connected to the internet at all. They even have printers that they will refuse to connect to the internet. They'll like plug it in order to print something because they believe that it's that insecure. So keep that in mind. Now there was, I forget which company it was, but there was a casino that had a fish tank that had a smart temperature sensor on it, and then it got hacked because it was an IoT device. Because it got hacked, they did that through their default username and password, and it wasn't segmented. So with that, they were able to hop within the network and steal information. Could it be due? Let me see. Could it? Could it be due this reason appliance control apps are getting migrated to smart home app? Um, yes and no, but smart home applications still aren't like I would say completely and totally safe either. All right, we have about 10 minutes left, so I need to get through a couple more things here. In short, the one thing you need to know is IoT devices are not secure. If you need to use them, either disconnect them from the internet or put them on another network. All right, so one of you before was asking, okay, how does data protection get managed? Who controls it, right? Well, there are a bunch of different control standards out there. One of them is the ICS, which stands for Industrial Control Systems. So there's also SCADA, which stands for Supervisory Control and Data Acquisition. So these are essentially two different entities that are used to monitor and control industrial operations. Now, specifically, I should say specifically, this is in relation to like power grids and power plants, facilities, water treatment, and factories. Okay. These are all very important systems because they are meant to protect accessibility to the things that we as humans need, which is water, electricity, and safety, right? Now, the reason why these systems need to be protected is because they're originally built for reliability, not security. There's a difference. Reliability means that we can rely on them. However, they're not as secure. Many of them are using a lot of outdated systems. Sorry, give me 1 second. A lot of them are using outdated systems, and then a lot of them are not lacking encryption, or maybe they're having some minimal authentication, right? A lot of these are pretty common when it comes to these because these industrial systems tend to be pretty outdated. Now, if they're connected to the internet, well, then there's an extra layer of difficulty because it increases the risk overall, right? Now, there are some security policies that you can do in order to mitigate this overall, right? One of the first things you can do is you can make sure to include logical segmentation or physical segmentation. Now, it'll be pretty tough to do physical segmentation or air gap it because more often than not, you do need to have these systems connected in order to monitor and update the systems as needed. But if you do logical segmentation and put these systems on their own segmented network, that can at least protect it a bit more. Then with these systems, even if they're outdated, you can put access control and logging in place, meaning you know who accesses what when. When there's downtime or when you want to do some patching and then obviously real-time monitoring. Okay, we just have a couple more slides left. Now, there is something called RTOS, which stands for Real-Time Operating Systems. So RTOS is it's essentially designed to run applications that respond instantly and predictively. So it is an active responder. So this is really common in the medical field and medical devices and aerospace as well as manufacturing equipment. I know that sometimes it's also used in military. In essence, it is an application that directly interacts with a certain event. Okay. So they prioritize high availability and predictability. Then the challenge here is that sometimes they make it difficult to implement and there are vulnerabilities that live within it. The other one is embedded systems. So embedded systems are computers that are built into devices to perform a dedicated task. Okay, so they often run an RTOS and a stripped down OS version. Okay, Now, the limitations are both these is that there's limited resources, so they can't run traditional security tools. They have hard-coded credentials, and so you can't change a lot of the passwords. And then there's no way to update or patch them because it's a little difficult to do so. Okay? All right. This one, you don't need to worry too much about because I think they run more into government sector. Okay. Let's go ahead and do some knowledge checks for these last 5 seconds before we go into the final one here. Okay, let's do this quiz thread. So in the quiz thread, let's go ahead. Question number 1. What is one key benefit of integrating security measures during the initial design phase of a system? Okay, we got a lot of people saying A. That is correct. So the benefit is that you get to identify and mitigate the risks early in the development. Well done, well done. Next question. Which of the following best describes function as a service in a serverless computing? Which of the following describes uh, function as a service? A, B, C, or D? A lot of people saying A again. That is correct. So when you use function as a service, you're essentially breaking them down into smaller functions that do a specific event or response. Well done. Question number 3. What is a fundamental benefit of cloud computing compared to traditional on-prem data centers? What is one benefit? Cloud computing. All right, everyone says A again. That is correct. It's more cost effective, it's more scalable, and it has more flexibility. Now, keep in mind though, there is a compromise when you're using cloud computing and implementing the third person there. Well, then you have a shared responsibility. Okay. And then question number 4, how does an air-gapped system differ from a physically isolated system? This one's a little tricky. Okay, a lot of people are saying A. Well done. That is correct. If you remember, air-gapped have no connection, meaning there is no physical connection. There's no wires. There's no connections to the internet. If there's physically isolated, that means they're physically isolated, but they can still be connected to the internet. Last question. What is a key advantage of on-premise environment? What is a key advantage of an on-premise environment? There was one keyword that I used there. You all said B, that is correct. So when we're talking about on-prem, one of the best ways to describe it is there is more control. For question 3, why not D? Um, I would understand why you would pick D for this, but in essence, it would be A for 3. Okay, finally. So let's talk about the final items here. Now, we talked about a lot of things. We really broke down the concept of architecture and infrastructure. As a reminder, architecture is the plan. Infrastructure are the things that are going to build out that plan. That's why we went ahead and dropped into all the different components and sectors of infrastructure because we want to make sure that we have the right devices and tools to implement said plan. Why do we need this? Because we need to make sure that we have the right security measures, the right controls to lower the likelihood of an incident taking place. We also talked about infrastructure as code. This is security by design, making sure that we are able to push out automated updates and automated patching or configurations as needed. We talked about serverless computing and then microservices as well as cloud computing. We talked about all of these elements, third-party risk management, in case anybody is interested in that. That's a really good point. Okay. And overall, everything in architecture influences your security posture. Okay. So from who has access to the data, how the data flows, and then who you allow access to. So anytime you're working with any sort of architecture or computing, it's always best to apply the principle of least privilege. You want to make sure that only certain people have access to certain things. You want to make sure that you include segmentation and visibility. And finally, one of the most important pieces is you need to make sure to keep up the CIA triad: confidentiality, integrity, and availability. All right. That being